Good morning. We are going to be looking at how to um, how to think about pixels when we are discussing making games. Almost all art that you're going to see on your computer is going to be pixel art. There are three main types of art styles that you'll find on your computers. One is pixel art, or known as raster art. One is vector art, and the last one is going to be fractal art. Uh, Fractal art is basically complex equations. Sometimes it could be a simple equation, but mathematics determines the shape and the color of the image. In vector art, we have basically 2 points with lines drawn between them, and the line is calculated by mathematics, which means if I zoom in, the the line will just get recalculated every time I click zoom on that line, and we should always have a perfect curve. In raster art or pixel art, the more you every time you zoom in, you can only zoom into a certain amount, and that is to its lowest point, a pixel. Pixel stands for picture element, which is a single block and which has a color. So if I look at an image, as nice as the image looks when we're zoomed out, as we start to zoom in on an image, we're going to start to see all the blocks that make up that image. So there are each and every single pixel in that piece. So pixel art is just using this style here of having each pixel. If you want to do retro games or old style games and you hear that term pixel art, what they're referring to is art that, yes, it's using pixels, but um, an image like this, when I zoom in on her sleeve, I could see sort of blurring around the edges. This is called anti-aliasing or anti-aliasing. I've heard many different ways of saying it, but I always say anti-alias. And this is that blurring that you see there is that pixel art for games does not have this blurring. It is all solid blocks. So here's an example of pixel art for a game. The name of the artist is Soap H, and I have his Twitter feed in my description. I have two Twitter feeds in my description, my favorite pixel artists. And this isn't using any blurring between one edge and another edge. So if I zoom in here, um, he actually hand drew those different colors to make it seem a better transition. But you can see this is more like large blocks and hard edges between the two of them. This pixel art is at a resolution of, let me center this, center, right. So image size, we're looking at a resolution of 1600 by 900. And be careful of this when you hear people talking about their images and how much resolution they have. So when they're talking about resolution, they're talking about their DPI. And if you hear them say resolution, they call two numbers, like 1920 by 1080. Yes, that is a resolution. But here in Photoshop, when they talk about this, they're either pixels per inch or dots per inch resolution, and they say, "Oh, I've got." You'll hear them say, "I've got 300 DPI." If they're talking about a camera shooting at, cameras will always talk about shooting in pixels, so you hear megapixels and stuff like that. Resolution in digital formats means nothing. This only has to do with printing. So, like for instance, at this resolution, if I printed this and you zoomed in, you would see 72 pixels inside of an inch on a paper. But on a monitor, this image right now, let's say it's filling my monitor. If I went to a big, huge monitor, this image will be filling the monitor. If I went to a tiny monitor, this image will be filling the monitor. It doesn't matter. The resolution of the screen is what matters. And that is not in pixels per inch or anything like that. But this image here saying it's 1900? 1600? 1600 by 900. That is the size so that this would fit on screen nicely. It's a nice image size. Right now, this is at 92.3. Let's see. Let's put it 100%. So at 100%, this is the size that we have. Let me see if I can just minimize that. Oh. Trying to, there. So that from edge to edge, that fills my monitor fairly nicely. But that's not the actual pixel size of this, I would say. It's harder to explain, but let me show you. Let's find a pixel. So remember, a pixel is a single element. And I'm going to look for a single pixel in here. Let's look over here. Because this block here should be this corner. Oh, there's a block there. That should be a single pixel, but it's not. 1, 2, 3, 4, 5. It's 5 pixels. So in other words, this image is blown up 5 times larger than it actually is. Let's go in here and put it back to normal, to what it should be. Let's resize it by percentage. And if it's 5, I guess that should be 20%. And we're seeing here 320 by 180. That's the original size of this picture. I could still blow this up and it still looks the exact same as before. But now, if I zoom in on that pixel, there it is. It's one single pixel. I'm going to save this image because I want to use this in Unity as an example. Now we're going to get to using pixels in Unity. And when we get in here, I've got a bunch of images. I've got an image that is white, which is one single pixel by one pixel. I've got a 10 by 10. I've got 100 by 100 and 1,000 by 1,000. If we drag these into here, we can see there's a difference between each of these. And it gets so small, you can barely even see them. So each of these images are all different sizes. So we can see how they look in there. Now, what I want to discuss right now is when we were in Photoshop, I talked about how pixels are for your screen. And pixels per inch is for printing. So when we get in here, so in printing, we can talk about inches, we can talk about centimeters, we can talk about millimeters. On our monitors, we're discussing pixels. So your average TV, your average monitor is going to be 1920 by 1080. That's called HD. And for that to fill the screen, I need 1920 pixels across by 1080 pixels tall. So I need those to fill my screen. In Unity, I have here my game window down here. This is what we see. I've got this set right now to full HD 1920 by 1080, which means I need something at 1920 by 1080 to fill this screen. If I take an image and I drag it into here, so here's my 1,000. So that's 1,000 pixels tall. But if you look here, it's filling from top to bottom. So why would 1,000 pixels fill top to bottom? It's supposed to be 1080 pixels to fill from top to bottom. So how could that possibly fill there? Well, when we're looking at our pixels in Unity, we also have to take into account that here in our game view, in my scene view, I have this grid. What does this grid represent? It's not inches, it's not centimeters, it's not millimeters, it's not even pixels. This represents a Unity unit. I drag an image in here. Let's not use that one. Let's use 10. There we go. I drag a unit in here and I move it around and I see over here minus 1.14, 0.31. Those are Unity units. How does that refer to our pixel images? We're bringing images in that are pixels. And I brought 1,000 pixels in, and it filled my screen, which it shouldn't have. So what is actually going on? Okay, there's a correlation between the actual images and their pixels and the units. I'm going to create another one, actually. Let's go to File, New, and I want to do one 32 by 32 pixels. In gaming, whenever you're creating stuff, it's always good to go with powers of 2. And so things like 2, 4, 8, 16, 32, 64, 128, 256, and 512, and 1024. So you always keep it somewhere inside of those ranges. I'm going to go 32 by 32 on this. And it's white, filled, save as. Hopefully it goes to the same folder. Nope. Desktop. RPG starter, assets, sprites, pixel training, and 32. PNG, yes. Save. Okay, and there he is. The default, when we start a project as a 2D project, when we have these images and I select them, if I had the image up here, there's my image. I have it up here, and I see up here that the options are for transform, its position, its rotation, and its scale in my scene. A sprite render, basically rendering the sprite to my scene. Those are the options for this picture as a game object. But if I just click on the picture down here in the asset area, so I click on that, I'm going to get the asset show up in here. This is talking about the image itself and how we process the image itself. The first thing I want to look at is I want to look at well, if we had set up our game as a 2D game, then this here would say sprite 2D and UI. We don't need to change that. If you accidentally set up your game as 3D and wanted to make a 2D game, you're going to have to constantly change that because it's usually set to default. I don't know. I can't remember what it's usually set at. I don't usually make that mistake anymore. But once it's set up correctly, you should see sprite 2D and UI. Next here, sprite mode, single. We're going to come back to that guy here. This is the important one that I want to look at though. Pixels per unit. So in Photoshop, we talked about pixels per inch. How many pixels can I cram into 1 inch when I print it? And this here, pixels per unit, how many pixels can I cram into 1 unit? So here is a unit. It says the default of 100. I do have a 100 sprite here. And I put it here, and we can see it fits perfectly inside of 1 unit. If I actually align this correctly, 0.5 and 0.5, right. That fits perfectly in 1 unit because I told it that this particular image, the image called 100, fits within 1 unit. I usually make my games with sprites that are like 32 or 64, those kind of dimensions. So here's a 32 pixel. I know that 1 unit, this image here, when I click on it, pixels per unit, 100. I can put this down in that corner there. And of the 100, so if I think from here to here is 100, this is 32, and going up, that's 32. So that looks correct. Here is the 10. So if I put the 10 in here, I should be able to get that there. Right. I should be able to get that perfectly as 10 units going across. So let's say this is -1. Nope, minus 9 point minus 0.95. There. Okay. So if I had that coming across, I could fit 10 of them within here, because he as well is saying that he needs 100 pixels to fill a unit. And he's only 10 pixels, so he's going to fill 1/10 of a unit. Okay, what happens if we start to play with the pixels per unit? This guy is 32. Let's grab 32. And I'm going to say it only takes 32 pixels to fill a unit. And I have to move. I have to apply that. Okay, now this is a lot larger. And what about this guy? He's at 10. What if I said that 10, it only takes 10 to fill a unit? Now the 10 fills an entire unit. Now, these images don't have any pictures to them. What if I actually had an image where, let's grab a normal sprite. So I have her, and she is at the tallest, she's 120. So if I said she was 120, apply, we can see from top to bottom she fits in that square. The more I start to increase, so I'm going to grab another one. Let's grab her. She is also 120. And therefore, if I click on her and I go up to, let's go to 20 or 24. Apply. We see she's a lot larger on the screen, but she's starting to blur out a bit. This is Unity trying to, so if I had her and I zoom in, she looks nice and crisp because her pixels are correct. I'm not scaling her larger than what her pixels should be. Also, hold on. Okay, that's also because I have something else set up for her. She is blurring even if I put her back down. So I had her at 120. I'm going to set also at 120 and apply. Okay. I'm going to drag them next to each other. And what's happening here? She is getting blurred. She isn't. The reason for that is that Unity is trying to make her image look nicer by blurring it. I don't want that. I want to see all the individual pixels. That's the reason why we have pixel art. So for her, this is the next part we're going to look at. So pixels per unit, that's going to tell us how many pixels of an image actually fit in a unit. Now let's look at down here. In our filter mode, it is trying to blur it to make it nicer. It's filtering it to make it nicer. I'm going to tell it no filter or point. So once I do that and I say apply, now we start to see it looks a lot better. The other thing to do is I don't want any compression. I'm going to say from compression to none. Apply that. So those are two steps when we're doing pixel art. Set the filter mode to point, no filter. Compression, none. Okay. When I start designing my games, I want to know, I know the size of the screen, and I want to know how big I want my backgrounds. So I might go retro, like that graphic that I had there, this one here. And let's see how this works in this scene. It is 320 pixels wide. So if I pull this up here, it's tiny in my screen. So that needs to be a lot bigger in order to fill the entire screen. I could do this. Oh, wait, first it's pixel art, which means I should go point, and I should do none. Okay. I could do this. I can grab size and zoom that up. Okay. That's one way of doing it. I never like to see the scale go past 1 on anything. You make your images the correct size for the scene. I do not like using scale that often. So I'm going to get rid of that. So how else can we rescale that image on the screen? Well, we can change its pixels per unit. So if I went up, let's say 190, we see that gets smaller. If I went down 32, we see it's starting to get larger. How would we do that calculation? Well, we could look at one of the units and compare it to the other. Oh, let's compare it to the camera. So here's the camera. That's what we're comparing it to, sorry. We're comparing it to the camera and what the camera sees, because the camera is going to be for the view. And let's look at our camera size. We've got our camera at orthographic projection, and we've got its size there, and it says 5. 1, 2, 3, 4, 5. 5 vertically is what our camera is giving us for 1/2, which puts us at 10. So I have 10 units from top to bottom. I need this to fill 10 units. If I look at this, I've got 180 tall. So if I went and said, oh, I want this at 180 pixels per unit, then the image fills 1 unit vertically. So vertically, I can fill 1 unit. But I want to fill 10 units now. So let's select that. And let's go 18. And all I did was I took it and I divided it by 10. So it's a very simple math that I could do there of saying I want 10 units tall, and therefore how much would it take to fill 1 unit, which would be the height of the image, and therefore divide that by 10. Okay, this is now a full screen image for my game. If I run my game, let's go to maximize and play. That's the size of my image. Once we've got our background size set up, I like this size, then everything else I'm going to get off of that. Where is my sprites? Here we are. And I've got a character. I think it's this one. Nope, that's potions. Where'd the character one go? Oh, these are the characters here. So let's select her. Drag her into it. And I believe these are already set up as point, no filter, and compression none. And I now have... Did it go up? Oh, there she is. So there she is in my screen. And let's compare some pixel sizes. So her pixels, you can see, are larger than the pixels of the background. This is where, when you're drawing your character and you've set up your... what is her pixel size? I have her at 16, and the background is set to 18. If I just went 18 on this and apply, I can now see that my pixels are the right size for this background. So she is on that beach. Let's see if she fits in this scene. Would she be a good fit for this scene? Maybe. I might actually go for graphic, probably a bit bigger than her. I'm not sure. Put her next to a bat. Yeah, you need a graphic bigger than her for this scene. So when you're designing your characters, design them on a background. Get a background going and design it on the background for the correct height. And once the background's brought in here, you have to make sure your background and your image line up. I do not want to have... So if she's supposed to be bigger, let's make her bigger. So let's put her next to that basket and make her bigger. Let's say she's that size. Yeah, that's her size for the... let's go a little bit smaller. That's her size for this game. Right? Her pixels, a lot larger than the background pixels. You don't want to have to do that in your games. You always try to keep consistency with the size of your characters and your size of your characters and your backgrounds. Hold on. Sorry about that. Okay. I think that's about it for my tutorial because I just mainly wanted to discuss unit size versus pixel size. And the thing with the pixels is as long as you know what is supposed to fill your camera, you can do all the calculations. I knew I wanted this background to fill my camera, so I just had to look at the camera settings, find out how many units the camera fills vertically, and therefore how many pixels have to fill a unit for my background. If I created this background, I said I want this style of background with this size pixels, I could bring that into here and get that to be the correct size. Once I've finished with that, let's say this is the shot that I want to see in my scene, and I say, okay, this works good. I could then go back to Photoshop. Is the image still open? Yeah. I can go back to Photoshop, and I can go to image, canvas size, 500 by 400. And now I can go and I don't know. Let's grab this. I'm using a mouse right now, so this is going to be horrible. Anyhow, so I'm going to extend my stairs going up. I'm not on my drawing tablet. So that the person could keep on walking up. Let's get some more grass over here. So I could extend this image. I'm going to save it now. Let's go back into Unity. And now the image has been extended. The pixels per unit are still the same. So let's say I've got my camera here. That means that here's my camera, grab the camera. If my character walks away from the beach, I could follow along with that. So I'm getting the pixels that I want in my scene. I'm getting the shot I want. But once I've got everything set up in a way I like, then I can move away. So normally in here, I would actually, so I know it's going to be 320 by 180. I'll start with a large canvas and I'll go something like this, new, 320 by 180. And delete the background. delete the background. Why are you not deleting? Oh, Control A, delete. No? Cancel. Let's create a new layer and delete that layer. Thank you. Okay, zoom. And let's select all and select modify border, I don't know, 5. And let's go for a red and fill. Deselect. That's a horrible, I don't like that. But anyhow, that's neither here nor there. And let's just take that and move it over to this image. Why is that not dropping? Mode. Oh, RGB color. Now I can do that. Okay, so once I have this in here, I can actually do some testing. So I can say, okay, that's what I want to see. I can kind of move this around and see what the camera sees just by creating this border. So I can follow the character walking up the stairs and know what I need to draw, what actually falls inside. Like, for instance, if the camera went from here, following up the stairs, then I can kind of draw a path from here to here and say, well, I don't see anything up here. So why bother drawing anything up here? I can just follow where the character can walk and what the camera sees and know what to draw and what not to draw. Okay, I can close Photoshop now. I don't need anything in there. All right, so that is my tutorial on pixels to Unity units and how Unity units and pixels work together. And that's how you could start setting up your games with the correct size backgrounds, the correct size characters, so that you're not going to have a situation like I had before where the girl, if I had to scale her up, her pixels will be different size to the pixels of the scene. She's supposed to be 16 pixels. Put her back to normal. Okay. All right, that is it. Thank you for watching, and I'm not sure what the next tutorial will be. Maybe I'll be continuing on the RPG journey, or I'll be continuing doing some introductory tutorials on how Unity works. That is all, and I'll see you later.